Okay, so we'll be starting with Spark SQL. As we know, Spark gives you the entire ecosystem, and similarly, like you had Hive in Hadoop, which was an SQL on top of Hadoop. Similarly, for Spark, you have a Spark SQL. Spark SQL is predominantly used for structured data processing. Structured data processing. You can create a SQL context, or you can also run Hive queries by making Hive context in it. For writing the queries, like you had an RDD in case of Spark that we saw in the previous classes, you have something called as a data frame. So data frame is a structure kind of thing, wherein structured data kind of thing, wherein on top of which you will be running the query. So you have a RDD in which you have a data, then you will be converting into a data frame and then run the query on top of it. We'll see how to do that. Okay, so yeah, that's it. We'll be starting with Spark SQL. Let's go and see. Let's say you have a data set 1, data set 2. So it is kind of optimized. Let's say you're writing a Spark core program, and let's say in a Spark core program, what you're doing is this is my data in 1 and 2. What I'm doing in Spark core, let's say I am making a RDD that is name is A, and then I perform join data set 1 and 2. Then I do RDDB and I do filter A by some column or by some condition. So you can see that I have done join first and then the filter. Will it be good if I do join first and then the filter, or will it be good if I do filter first and then the join? Which will be more fast? First join, then filter, or first filter, then join?
Filter and then join.
Filter and then join,
Filter
because
first.
yeah, data will get reduced and then you will be doing
First,
join.
and a first will be like join.
No, first if you filter this, let's say you are doing a filter on data set 1 or data set 2. If you do that filter, your data will reduce, right? Let's say currently it's this big data. So first you are doing a join and then doing a filter, so it will take more time. If you did a filter first, so this data becomes this small and this data becomes this small. Then if you do the join, it will be more faster, right? Getting the point? Okay. So this things we need to take care in Spark Core. In Spark Core, we need to take care that if I am doing some such kind of operation, I should do filter first and then the join, so that it is more faster. And even the RDDs have less data. But in case of Spark SQL, it is optimized, and it uses a optimizer called as a catalyst optimizer. So let's say you write a join condition. Maybe I'm just writing a simple query: select star from ds1 comma ds2 on join something on field A is equal to field B something, and field C is not equal to phi, D is not equal to 7, something like this. So in this case, let's say I'm writing this in a Spark SQL. What it will do is it will always perform this filter first for you. It will perform the filter first for you. This is filtering something. So I am reducing some data, and then it will perform the join on these two tables using this particular column. So this thing is done automatically by a catalyst optimizer in case of Spark SQL, but in case of core Spark, you need to do it, or you need to take care of it. Other way also it will work. This way also it will work. You can also do this way, but if you are doing the filter first, then your data will reduce and it will be more faster. So in case of Spark Core, you need to take care, but in case of Spark SQL, you don't have to take care. It will be taken care by Catalyst Optimizer.